All right, guys, we're going to look at the attributes of parabolas. So it looks like parabolas, but it's not parabola, it's parabola. So what we're going to look at first is some main, very, very, very important vocabulary. And then we'll kind of look and use that vocabulary for the graphs of our parabolas. So to talk about a parabola, it's going to be a U-shaped graph as a result of a quadratic equation, which basically has an x squared term in it. So, let me. So it's a U-shaped function. It's from a quadratic, which means it has an x squared term in my function. So a couple of things about the parabola is that it's going to probably, more than likely, cross the x-axis in a couple of places. So those are going to be our zeros, or that's also known as your x-intercept. So the zero is also the x-intercept, which is where the graph or the function crosses the x-axis. So this is a little bit different from the linear function. We were way more concerned with the y-intercept. You may still be asked to identify the y-intercept, but the x-intercepts are huge when we talk about parabolas. So the vertex at some point, the U is going to stop going down and start going up if it's shaped like this. But if it's basically an upside U, which is an N, it's going to stop going up and start going down at some point. So that's going to be that vertex. So it's either going to be a maximum if it is at the top, or it's going to be a minimum if it's at the bottom. Okay, this at the very bottom of the parabola. The axis of symmetry. So another thing that makes parabolas really nice is that it's going to mirror across that vertex line, which is also that axis of symmetry. So this serves as a mirror. Okay, so it's going to reflect back and forth across the axis of symmetry. It's also x equals negative b divided by 2a. That's going to be kind of sort of important a little bit later on. And so but it's going to be a vertical line always, always, always. So let's take a look and apply this to a couple of graphs. So first, this is a parabola. For example 1, you can see it makes a U shape. So let's start off by identifying my zeros or my x-intercepts. That's going to be right here at -1 and at 3. So if I'm going to write them as a 0, I'm going to say the zeros are and I'm going to say x equals -1 and x equals 3. Then if I want to write them as x-intercepts, I'm going to say -1, 0, because I'm going left 1, up 0, and then also have an x-intercept at 3, 0. So it kind of sort of depends on what they're asking you for. So they're asking for the same thing, but sometimes they may use different terminology there. All right, so those are our zeros. We're now looking at the vertex. So the vertex is here. This is going to be my vertex. I'll go ahead and label these. All right. And so our vertex is at that bottom point. So you can see it's going to go down to a certain point. That's going to be called a minimum, and then it's going to start going back up. So our vertex is at a minimum, and the point is going to be 1, -4. So a lot of times just identifying that vertex and knowing what the vertex is, big key thing. And then the axis of symmetry is going to be right here. It's going to go through the vertex. It's a vertical line that goes through the vertex. So it's going to go right here. This is going to be my axis of symmetry. And so from here, my axis of symmetry is going to be at x equals 1. Also, you can see my vertex is at 1, comma -4. So those two numbers should line up and be the exact same there. So x equals, once a vertical line, it's always going to be x equals, and it's always going to be a vertical line. It's never going to be a horizontal when you talk about a parabola. And so what you can see is it reflects back and forth. The parabola is going to go back and forth between there. It's again symmetrical, which means it's the same on both sides. And then we also can, now not always, but occasionally they will ask you to look at the y-intercept. So that's going to be right here at -3. Not always, but sometimes. But you guys know that's where it crosses the y-axis. So that is going to be y is equal to -3, or also as -3, 0, comma -3. So those, all of that kind of putting in there together. So now let's look at another example. We're just going to go through this so you can see it looks like an N, or it's not necessarily U shape, which makes our vertex is going to be a maximum. So let's start off first with our x-intercepts and our zeros. So remember, that's where it crosses the x-axis. So I have 1 at -7, and so I have -7, 0, and -1, 0. So those are, remember, also called our zeros. So again, they may say the zeros are at x equals -7 and x equals -1. So again, those mean the same thing. They're identified the same place. They're called different things and maybe written a little bit different. When you write it as an x-intercept, you want to write it as an ordered pair. When you ask for zeros, almost kind of solution-y there as well. Now let's look at our vertex. So our vertex is right here, and that is at -4, 9. So our vertex this time is a maximum, okay? And so that is going to be at -4, 9. And then we have our axis symmetry. So our axis symmetry, remember, goes through that vertex and it's going to reflect back. It's going to be a vertical line every single time. And so our axis of symmetry is going to be at x equals -4. X equals -4. And then we cannot see the y-intercept. It would happen somewhere else, so we won't identify that or even try to guess what that is going to be at this point. So main key things is that, remember that zeros and x-intercepts mean the same thing. It's where the line crosses, or excuse me, not a line. The function crosses the x-axis. So here we have two of them because they're going to cross in two places. Not always two. Could be one. Could be none. We have a vertex that's going to be either a maximum, which is going to be the top part of my function, or a minimum, which would be the bottom part of my function. And then the axis symmetry is going to go through that vertex straight down the middle. It's going to act as like a reflection line and mirror back and forth. So again, a lot of just looking at the graph and applying these vocab words to that graph and moving on from there.